Again, welcome to lecture number 5. This is Mathematics 200 Business Calculus. In lecture number 5, we are going to cover the product and also the quotient rules in derivative. That is the product rule and quotient rule in derivative. Last time, in lecture number 4, we covered the constant, the power, and also the addition and subtraction rules. As time goes on, I'm going to make a video that we are going to solve some examples in a Blackboard. So this is just a lecture. So again, our main objective today is to cover the two rules, which is the product and quotient rule for derivative. So let's start with the product rule first. So we know that in mathematics, a product, for example, f at s equal to s times x, we'll say that it's the same as writing f at s equal to s squared. That's in a regular, again, mathematics, college algebra. A product of two items, we multiply them together. But in derivative, we have a rule for that, a product rule. And this is how it goes. Now, if I have a function, f at x, and it has two terms, and they are multiplied, let's say we have u at x times v at x. I cannot say, okay, u at x term, let's say u at x is 3x and v at x is 2x. I cannot say the answer is 6x squared. No, we can't do that. We cannot. So we use the product rule, which will say that first multiply u at x times the derivative of v at x, then plus multiply v at x times the derivative of u at x. It doesn't matter which one you do first. I can say, okay, derivative of u at x times v plus derivative of v at x times u at x. Or the opposite, u at x times derivative of v at x plus v at x times derivative of u at x. So this is the rule. Again, this is the rule. We cannot say, okay, f at x equal to u at x times v at x. So the answer will be u at x times v at x. No. It says, find the derivative of u at x times v plus derivative of v at x times u at x. It doesn't matter which one first, whether derivative of v first or derivative of u first. We get the same answer because 2 plus 3 is the same as 3 plus 2. Remember, we have addition here. So we're going to see an example here. Here they say we should find the derivative of y equal to 2s cubed plus 3s plus 1 times s squared plus 4. Now, I have a multiplication here. So in this case, I have to use the product rule. So this is f at s equal to 4s cubed plus 5s squared minus 6s plus 5 times s cubed minus 4s squared plus 1. So I can find the derivative of the first function, which is 4s cubed plus 5s squared minus 6s plus 5 times s cubed minus 4s squared plus 1, then plus the derivative of s cubed minus 4s squared plus 1 times 4s cubed plus 5s squared minus 6s plus 5. And that's the product rule. So let's see how this problem was solved. So u at x is 2s squared plus 3s plus 1. And v at x will give me s squared plus 4. Using the product rule, this is what we get. Now we find the derivative of the first term. So we get 2s cubed plus 3s plus 1, because we are looking for the derivative of s squared plus 4. Derivative of s squared plus 4 will give me 2x. We know that rule already. This is the sum rule. This is the power rule. S squared will give me 2x. Derivative of a constant is 0, so we get 2s. Times what? 2s cubed plus 3s plus 1. Now second, plus derivative of 2x cubed plus 3x plus 1, which will give me 6x squared plus 3 plus 0 times x squared plus 4. And that's what we have here. 6x squared plus 3 times x squared plus 4. Now we can simplify this expression if we want to. But the main thing I want us to understand here is that when we have a product, the first term here multiplied by the second term, 2x cubed plus 3x plus 1 multiplied by x squared plus 4. I'll find the derivative of the first term. It doesn't matter, you can do the first term first or the second term. But let's say I'll find the derivative of the first term, then I'll multiply by x squared plus 4. Then I'll find the derivative of x squared plus 4, then I'll multiply by 2x cubed plus 3x plus 1. Plus, we had them. So that's what we did here. We find the derivative of x squared plus 4, which give me 2x, times 2x cubed plus 3x plus 1. Plus, now we know the derivative, we use the derivative here, so we have to find the derivative of 2x cubed plus 3x plus 1, which will give us 6x squared plus 3. And that's what we have here, times the second term, x squared plus 4. Then from here, we can simplify the equation. So we remove the parentheses. 2x multiplied by 2x cubed will give me 4x to the power 4. Plus 2 times 3 is 6, s times s is s squared. Plus 1 times 2x will give me 2x. The same thing here, s squared times 6s squared will give me 6 to the power s4. Plus s squared times 3 will give me 3s squared. Plus 4 times 6 is 24s squared. Then 4 times 3 is 12. Then we can combine the like terms. So we have s to the power 4, s to the power 2. We have to combine them. So our final answer will be 10 s to the power 4. Why? Because we have 4 here and we have 6 and it's plus, so it's 10. Then s squared, so we have 6. And we have 3, 9, 24. That'll give me 33s squared. Then we have only one 2x and only one constant value, which is 12. So that will be our final solution. Again, the product rule means find the derivative of the first term times the second one, plus the derivative of the second times the first. So this is the second example. If we quite remember, we have 4s cubed plus 5s squared minus 6s plus 5 times s cubed minus 4s squared plus. So I find the derivative of the s cubed minus 4s squared plus 1, which will give me 3, again, power rule. So this will be 3s squared minus 8x times the first term. And that's what we have here. 3s squared minus 8x times the first term. Plus, the first term is 4s cubed plus 5s squared minus 6s plus 5. So the derivative of this will give me 12s squared, and that's what we have here, plus 10x minus 6. That's what we have. Then we multiply it by the first term, which is, again, let's go back, s cubed minus 4s squared plus 1. S cubed minus 4s squared plus 1. And that's what we have here, s cubed minus 4s squared plus 1. Now we can remove the parentheses. But in this question here, I think they tell us, let's go back to the question. They say we should find the slope. So at the point where x equal to 0, x equal to 1, find the slope of the tangent to the graph. So when we find the derivative finish, we substitute the value of x to be 1. And that's what we did here. The question says we are looking for the slope when x equal to 1. So we substitute x equal to 1 into the derivative of f at x. So the solution here, we substitute s 1, 1, 1 throughout. And this is what we get. And the final answer will be negative 72. I don't want to explain this because this means I have 1 cubed minus 4 times 1 plus 1, 12 times 1s squared plus, and just simplify it. You get the solution. So let's go to the quotient rule. Again, it's not regular algebra whereby I will say, okay, s cubed divided by x, the answer will be s squared. No. In derivative, we have a special quotient rule. And this is how it works. So if I have u at x divided by v at x, it's not the same as say, okay, u divided by v or whatever. Let's say u at x equal to 6 and v at x equal to 2. I can't say 6 divided by 2. No, we cannot. This is a derivative. So the quotient rule said, okay, this is very important. We remember in the product rule, we said it doesn't matter if u at s times v at x, it doesn't matter also, okay, derivative of v at x times u at s plus derivative of u at s times v at x, or the other way, derivative of u at s times v at x. Which one you do first then? Because 2 plus 3 is the same as 3 plus 2. By here, we have to pay very serious attention because we have negative. 2 minus 3 is not the same as 3 minus 2. So always, again, always we find a derivative of u first. So derivative of u at x times v minus the derivative of v times u at x. Always, because why? 2 minus 3 is not the same as 3 minus 2. But if it's plus, it doesn't matter. 2 plus 3 is the same as 3 plus 2. So that's why we again always find the derivative at the of the numerator, then multiply by the denominator, minus derivative of the denominator multiplied by the numerator, all divided by the denominator square. So here we have v at x or square. And that's the rule. Again, v at x times derivative of u at s. Why derivative of u at s? Because that's the numerator. Minus u at x times what? Derivative of the denominator, which is v, all divided by the denominator or square. So let's see an example that will be more better for us to understand. We have 2 examples here. Let's do the first one. First one said we have f at x equal to s squared minus 4x divided by s plus 5. So we should find the derivative of f at x. So this means, again, I'm going to find the derivative of s squared minus 4x times s plus 5 minus derivative of s plus 5 times s squared minus 4x, all divided by s plus 5 squared. Then we simplify the expression. So let's see. What is the denominator? The denominator again is s plus 5. So we bring s plus 5 at the top, multiply by the derivative of what? The numerator, which is what? S squared minus 4x. So it will be s squared will give me 2s, 4s will give me 4. Minus derivative of the denominator, s plus 5. Derivative of x is 1, derivative of 5 is 0. So we get 1 times the numerator, which is s squared minus 4x. Everything divided by the denominator square, which is s plus 5 all squared. Now we simplify the expression. We remove the parentheses. So s times 2s will give me 2s squared. S times minus 4x will give me again minus 4x. 2 times 5, 10x. 10x, then 5 times negative 4 will give me minus 20. Then we know 1 times s squared minus 4s will give me the same s squared minus 4s. But here we have negative, so the signs change. Negative x squared, positive 4x. Everything divided by s plus 5 all squared. Then we combine the like terms. 2s squared minus s squared will give me s squared. So that's a very nice example. As we said earlier, let's go back one more time. We can see that here we have s squared minus 4s is our numerator, s plus 5 is our denominator. So we find the derivative always, this is a quotient rule, always, because we have a minus between. So always we find the derivative of the numerator, s squared minus 4s times s plus 5, minus derivative of the denominator, s plus 5 times s squared minus 4x. Everything divided by s plus 5 all square. So with the product rule, since And we are going to get two different terms, but it's plus. It doesn't matter which one we do first. So we can say 2 plus 3 is the same as 3 plus 2. But 2 minus 3 is not the same as 3 minus 2. So as I said earlier, always we have to find the derivative of the numerator first times the denominator minus derivative of the denominator times the numerator, all divided by the denominator square. And that's what we have here. So we simplify the expression, and this is what we get. Also, we can look if we can be able to factorize the trinomial so that we can cancel 1x plus 5 if it's possible. If not, then we leave the answer as it is. Now, in the second part, they give us, let's go to the original question. They say, if f at x equal to x cubed minus 3x squared plus 2 divided by x squared minus 4, we should find the instantaneous rate of change of f at x when x equal to 3. Now we spoke about, I think, lecture number 3 about what we mean by instantaneous rate of change. Anytime they say we should find this rate in calculus, our goal is that we always find the rate of change of something, an object, or so instantaneous rate of change means the first thing we have to do is find the derivative. Then when you are looking for instantaneous rate of change, you always have a x value. Now, if I'm looking for rate of change, it will be between an interval, let's say from 3 to 5. And we did that also. So this means the first thing I'm going to do is to find the derivative first. So this is quotient. So I have to use the quotient rule here. So again, that's the quotient rule. Again, we went through this. So let's go through the second question. So this is the second question. So the first thing I will do again, I'll find the derivative of the function first. So we always have to find the derivative of the numerator. X cubed minus 3x squared plus 2 will give me 3x squared minus 6x plus 0. So we get 3x squared minus 6x times the denominator, which is x squared minus 4, minus the derivative of the denominator. X squared minus 4 is what? 2x, times the numerator, which is x cubed minus 3x squared plus 2. Everything divided by the denominator square. So we simplify this expression. We are going to remove the parentheses, and that's what we get here. 3 times 3x squared, x squared give me 3x to the power 4. And also x squared times 6x will give me 6x cubed. It's negative positive, so it's negative. 4 times 3 is 12. It's negative positive, so it's negative, and the x squared. Negative will give me positive. 4 times 6 is 24, and the x. Then we do this separately. 2s, s cubed will give me 2s to the power 4. 2s times 3s squared will give me 6s cubed. 2s times, and everything is positive. 2s times 2 is 4x. Remember, we have negative here, so all the terms in the parentheses here will change, the second term. And that's what we did. Then we combine the like terms, and this is what we get. Now look if it's possible that we can factorize the trinomial and get at least x squared minus 4. If it is, then we do it, then we cancel. If not, remember this question said we should find what? The instantaneous rate. So when s equal to 3, so we're going to substitute s value to be 3. And when we substitute s value to be 3, do your calculations, we get 33 by 25, which is 1.32. And that will be the instantaneous rate of change. Anytime we are looking for instantaneous rate of change, remember at a specific time. Rate of change at specific interval of time. So they will remember we say f at b minus f at a divided by b minus a. That's if you are looking for rate of change. By instantaneous rate of change, just find the derivative first. Then when you get the derivative, you substitute the value of that specific time S value. So that will be the conclusion of product and also the quotient rule. If you like this video or comment it, I always welcome a negative comment. And this channel is very new, so I'm trying to improve it as time goes. And also subscribe it if possible. Thank you.